My dear students, welcome back. A very good morning to one and all. I hope you and everything is fine and safe around you. Coming to the DBMS course, in today's session we will cover another concept, that is the structure of a DBMS, also called as architecture of a DBMS. In the previous sessions we covered what is the meaning of data independence, what is the data abstraction, what are the different DBMS languages, those things already we have discussed so far. In today's session we will concentrate on structure of a DBMS. So DBMS architecture depends upon how users are connected to the database to get their request. So here the DBMS architecture is helpful for request and responses. Suppose we will open the Google website, Google. In that we will searching for any information. Suppose I am searching for DBMS architecture. So simply I will type the DBMS architecture in the Google. That is my request. And database point of view elanti process jarugutundo manaki ikkada teliyadu. Just here we have the front end users only. So here the architecture depends upon how users are connected to the database. Okay, how we will connect to the database. Already in the data abstraction we have discussed one point. The users are not directly connected to the DBMS. In that point of view we have three levels: view level, conceptual level, physical level. In that only the physical level users are directly communicated with the databases. Okay, so that's why here the DBMS architecture depends upon how users are connected to the database to get their request done and how the response is received from the database. So actually this is the client or server architecture used to deal with a large number of PCs, web servers, database servers and other components that are connected with the network. Here our aim is to communicate with the suppose our aim is to search any information. In that time definitely we will use any network. So this is very simple client or server communication, okay, via the network. Here we have three different type of architectures are there. So one tier architecture, two tier architecture, three tier architecture. But logically we are only discuss about two tier architecture and three tier architectures only. One tier architecture means simply we will communicate directly with the databases. Suppose for example our systems are used by us only, okay, our mobiles are used by us only. In that time that means that is one tier architecture. మన పర్టికులర్ డేటాబేస్లో ఏదైతే డేటా ఉందో దాన్ని మాత్రమే యూజ్ చేయగలుగుతున్నాం, డైరెక్ట్గా దానితో మనం కమ్యూనికేట్ అవ్వగలుగుతున్నాం. సో that's why the one tier architecture is negligible. Here we will more concentrate on two tier and three tier architecture only. The programmers are also working with the two tier and three tier architectures only. Okay, now we will discuss one by one. What is the meaning of single tier architecture? Single means one tier architecture. In this architecture the database is directly available to the user. That means మన ల్యాప్టాప్ మనమే యూజ్ చేసుకుంటున్నాం, మన పీసీ మనమే యూజ్ చేసుకుంటున్నాం, మన మొబైల్ మనమే యూజ్ చేసుకుంటున్నాం. సో అది యూజ్ చేసుకోవడానికి ఇక్కడ మనం ఎలాంటి అదర్ టూల్స్ని కూడా యూజ్ చేయట్లేదు, ఎలాంటి అదర్ సాఫ్ట్వేర్స్ యూజ్ చేయట్లేదు. దట్స్ వై దిస్ ఈస్ ద సింగిల్ టైర్ ఆర్కిటెక్చర్. ఇట్ మీన్స్ ద యూజర్ కెన్ డైరెక్ట్లీ sit on the DBMS and uses it. So we will consider our system as a database management system. So we will perform all the operations, okay, we will access anything in front of the system. So that's why that is the best example of single tier architecture. Any changes done here will directly be done on the database itself. Suppose we will maintain the database, okay, for the understand point of view I will discuss our own laptop. Suppose we will maintain our own database. In that we will change anything directly be done on the database itself. It does not provide any other tools, okay. In the one tier architecture is used to development of the only the local applications. Suppose we will implement one application in our system, then just here we can use only, okay, the others are not communicate with those applications, okay. So this is used for to develop the local applications only. Here we can directly communicate with the database for quick responses. So here this is our the system represents the user, the rectangle represents the database. Here we will directly communicate with the database. Any other softwares are involved here, that's why this is the single tier architecture. Coming to the two-tier architecture, here in the two-tier architecture is the same as basic client-server communication. Just suppose here in the Google we are searching any information. In that point of view, we are using the two-tier architecture. In the two-tier architecture, applications on the client can directly communicate with the database at the server side with the help of the interaction the application programming interfaces like JDBC, ODBC. Here in this point of view, we will communicate with the databases. The mediators are application programming interfaces like JDBC, ODBC communication. So with the help of JDBC, ODBC, here we will directly communicate with the databases. Okay, here the mediators are JDBC and ODBC, Java database connectivity and the Oracle database connectivity. With the help of JDBC, ODBC, here the users are communicating with the database. So that's why here the helpers are JDBC, ODBC. That's why this is the two-tier architecture. The user interfaces and application programs are run on the client side. Okay, here the user interfaces and application programs are in front of the client side. We are the users, that means we are the client side client side users. At the server side, actually the functionalities like query processing, transaction management, here we are the users, we will give the request, so that means we are the clients, and system gives the response. In that time they are the server side. Okay, in that process what are the functionalities like query processing, transaction management, like that. To communicating with a database, client side application establishes a connection with the server side with the help of JDBC, ODBC or other application programming interfaces. Actually we have a lot of application programming interfaces, but we are using JDBC, ODBC because of that database connectivity provided by JDBC. All the multinational companies are using the Java, so JDBC well and the best database connectivity is the JDBC. So here please observe here the user aim is to search to request for the any application programming. In that point of view, here we will communicate with the server. Here the application client working as the application program interfaces. So this is the two-tier architecture. Now we will move to the three-tier architecture. Actually maximum the three-tier architecture is used in the large databases applications, large web page applications. Normally generally we are not using the three-tier architecture. So here please observe the previous diagram and this diagram. So in the previous diagram, client side only the application is there, here no application is available at the server side, but here you will observe the application server also. That's why this is the three-tier architecture. Actually here another layer is available between the user and database. That's why this is the three-tier architecture. In this architecture, client can't directly communicate with the server. Here the application server is the mediator for the database and application clients. So application server. Next, end user has no idea about the existing of the database. Here there is not directly communicated with the user and database. That's why user details are not observed by the database details are not observed by the user. Here no idea about any other user beyond the application. So this is the information about three-tier architecture. Three-tier architectures are used in the large database applications only, large web page application development. So this is the DBMS architecture. Now we will discuss about some other diagram also based on the relational model. The DBMS architecture is shown below. Actually this is the textbook DBMS architecture according to the database management system textbook architecture. Actually this architecture is developed within the help of relational model. Here you observe three layers. Actually in the data abstraction, three views are there. What three levels are there? View level, conceptual level, physical level. Here we will observe those three levels. Here web forms, front end users, SQL interfaces, these are the view level. That means these are the users. With the help of SQL commands, this information is passed to the conceptual level. In the conceptual level, here standard query language engine is there. In that, plan executor, parser, operator evaluator, optimizer are there. Based on their working, based on their responsibilities, these are responsible for some information. Now we will discuss about that. In the DBMS, that means physical level. Here the physical level is directly communicating with the database. In that physical level, here transaction manager, lock manager, files and access, buffer manager, disk space manager, recovery managers are there. Here they have some responsibilities. Now we will discuss about those responsibilities. Here the physical level is directly communicating with the database. In this database, data files and index files are available. One system catalog is also available. What is the use of that system catalog? What is the meanings of these things? Now we will discuss about that. Web forms. Generally we are using the internet, means suppose we will search some information. That means we are searching for some web page applications, web forms. Actually web forms are pages that your users request using their browser. Simply we will sit on the one PC, open the Google Chrome or any web browsers, simply search some informations. Okay, those are the, in that time the web pages are displayed. The user interface of web page is observed by the users. Okay, so coming to the front end users, here we have front end users and back end users are two different types of users. Front end users means clients or users. Okay, back end users means server side working programmers. Okay, here the front end user working is to search any informations. So here the SQL interface, structured query language or standard query language interfaces are for manipulating, retrieving the data from the databases. Okay, these are the points regarding web forms, front end users, SQL interfaces. SQL interfaces for manipulating, retrieving the data from the databases. With the help of SQL commands, this information goes to the conceptual level. In this conceptual level, the structured query language engines are there. In this point of view, plan executor, parser, operator evaluator, optimizer are there. What is the working of plan executor? This is also called as query plan or query execution plan. Actually it is a sequence of steps used to access the data. Suppose what is the user's aim? To accessing some data. So in this point of view, this is planned to execute that query. Okay, that question. Okay, next parser means parsing step by step. Okay, the process by which this decision making is done, that for a given query. What is the question? Based on that question, it takes the decision making. Okay, operator evaluator, so it performs the some operations. Based on those operations, the SQL engine working is done. Optimizer, optimize means minimizing, as ఎంత possible అయితే అంత. Here the structured query languages are optimized. This is the working of standard query language engine. Next, coming to the DBMS, that means physical level. Here transaction manager, lock manager, files and access, buffer manager, disk space manager, recovery manager are there. So they have their responsibilities. What is the responsibility of transaction manager here? Actually it is responsible for coordinating the transactions. What is the transactions done by the web pages, by the users, like that. Coming to the lock manager, actually it manages the locking requests. made by the transactions. That's why some relation between transaction manager and lock manager. Coming to the files and access, actually here two file access are there, sequential and random files access. Based on their requirement, their work is going on. Here we have lot of methods are available for accessing. Okay, in the upcoming sessions we will discuss about depth on those concepts. Coming to the buffer manager, actually it is responsible for bringing pages from the physical disk to the main memory. Okay, that is the responsibility of buffer manager, bringing pages from the physical disk and transfer it to the main memory. Coming to the disk space, actually it takes care of allocation, deallocation of the pages. Coming to the recovery manager, already in the name also available, recovery. So it is responsible for backup, restore, recovering the database files. This is the information about these DBMS concepts: transaction manager, lock manager, files and access, buffer manager, disk space manager, recovery manager. Okay, so each and every concept have their responsibilities. Based on the responsibilities only the working process is going on. Coming to the database, in this index files, data files, system catalog is there. So index files, actually it is a data structure technique. Why we are using this technique? Because it efficiently retrieve records from the database. For that point of view, we are using the index files. Coming to the data files, actually these are the operating system files that stores the data within the database. Okay, the data files working is stores the data within the database. Coming to the system catalog, it is a collection of tables and views. It is a collection of tables and views, means users information like that, that contain important information about the database. Okay, the system catalog is working on the storing of collection of tables and views. Actually, why we are using this point of view? It stores the important information about the database. This is the explanation about DBMS architecture. Actually, here we have 4 different kinds of information: web forms, front end, SQL interfaces, SQL commands are user level, SQL engine is related to conceptual level, DBMS is related to physical level, finally the database is related database. Okay, these are the 4 types. So that's why I am also divided into 4 categories. Web forms, actually here the customers, travel agents, those are available. What is the meaning of application front ends? Here the front end is what a user sees and interacts with user interface. SQL interfaces, in that application programmers, database administrators are there. So with the help of SQL commands, they move to the queries move to the standard query language engine. In this, the working is depending on plan executor, parser, operator evaluator, optimizer. Next it goes to the final level, physical level. In that, transaction manager, lock manager, files and access methods, buffer manager, disk space manager, recovery manager. Here they have their responsibilities. Based on those responsibilities, those managers are working. Finally, the database, in that index files and data files, system catalog is there. Okay, so this is the information about DBMS architecture, structure of DBMS. Thank you very much for listening. Thank you.